Hello guys, today we have a very important lesson about fixing Indian inverters. Indian inverters like sukam and microteck and all the others. The lesson today is about scoping the square signal for all the MOSFETs that are installed in this inverter. And regarding this, you will find little in the internet. A lot of Indian videos are there. They are in Indian language. They are misleading because uh, the author of the video is saying that it is in English. They write the lines of the video in English, and all the contents of this video seems to be in English, but when you actually click on it, you find it in pure Indian, which will not work. So let's start. Before going to this scope, let me talk a little bit about this inverter. So there are 4 clusters of MOSFET. These 3 together, these 3 together, these 3 together, and these 3 together. Those 3 are called the cold-sided MOSFET, which means that their emitter is actually connected to the battery minus. These are the easiest to scope. You only have to put your probe between source and gate and do some magic here in the oscilloscope and the signal will appear. Those 2 are the high-sided. Even though you do all the magic, they will not work. They will not work until you install MOSFETs here. One here in this cluster and one here. You maybe choose to install all the 3, but I recommend just one for testing. One here and one here. About the theory why we install a MOSFETs here in order for the square signal, which appears to be very illogical, but try to write boost trapping and high-sided drive. You will understand what I mean. So this is an electronic subject called high-sided driving, and when you just browse this subject, you understand what I mean. But for now, you have to only recognize that you have to put MOSFET here and MOSFET here. But before you put the MOSFET here and MOSFET here, you have to scope those 2 and know that there is a signal. Then you can put 2 MOSFETs in order for you to scope those 2. Now the scoping step for all the cluster is the same. But just for the above cluster, no matter what you do, nothing will appear. But if you do those MOSFETs, then the steps for scoping this is the same as steps for scoping this, the same as steps of scoping this, which is like this. First, you have to set your trigger. What is triggering? Triggering is allowing your oscilloscope to be like a hunting dog, waiting for signal in an eager way, and even though the signal appear very briefly, he capture it and bring it out to you. So we will make, because these signals appear for a fraction of second, it will not allow you to capture them very easily. This is the problem of the Indian inverter. There is too much trouble for you to see the signal. But today we make a complete video about this. And you, of course, have to believe me that I have actually scoped this with these tips. And now it's time for me to scope those 2. I mean, it's the board is inverted. Those 2 actually the cold. Those 2 are the hot-sided. Those 2 having their emitter or source in the battery. So we are going to scope those 2. Let me go to the scope setting. You have to trigger and put edge trigger and source channel 1, rising edge. These are what you know, and you have to maybe click on this high frequency reject, because I find it very useful, because the moment when I turn on the inverter, some noise is actually interpreted by my scope as a signal, and then he freezes and bring you this trash signal as though it's a real signal. So when I make high frequency reject, I stop all this nonsense and convince my scope to bring me just the useful signal. After you set up all this, you have to go here, and there is a run stop and there single sequence. So you have to make single sequence which will allow your scope to be like a hunting dog waiting for you. And now everything is set up. We'll see what happened in the scope. Wow, just wow. I've been able to scope it. Now we can look at it, go into the time division, calculate how much it is, see if it's really square, do the magic with it. So that's all about this video, because this signal will never appear in the normal mode. But when you make the trigger, when you ready your scope to be like a hunting dog, it will bring you the signal, even if it's actually in a fraction of a second. Now I have done this here and here, so no time to me to scope all those four, but you have to believe me that they appear. The only thing that will face you, that when you scope those two, the signal will appear. When you scope those two, the signal will not appear until you install MOSFETs above, because this is a part of theory called bootstrapping and high side MOSFET driving. So when you browse this subject, you will understand why putting a MOSFET in the bottom will allow you to scope the signal above. It's very tense and long subject, but you have to study it in order to. But you have to believe what I did, and then first you scope those two without anything special, but this setting of scope, which are common for all the MOSFETs in this type of inverters, where the signal appear for a fraction of a second. Then after you finish scoping, you put your MOSFETs, you solder them, and you go to the bottom side and do the same steps regarding the scoping and readying your scope to capture the signal. And you get the signal and you enjoy it. And pretty much the inverter, once installed once the MOSFET installed and everything checked, like resistors and diodes, if nothing shorted or semi-shorted, because if they shorted, there will never be signal. But pretty much the inverter will work. I hope you enjoy this nice video, and I hope this video actually will cure your anger about all these Indian videos that are they having the address of the video like in English, and then when you go in find it all in Indian. So I recognize that I have to do it for myself and provide it for the electronics community. Thank you for watching and enjoying this video. I hope you benefit a lot from this video, and see you soon, and goodbye.